In the last video we saw that this function length takes a pointer as a parameter and copies it to makes a temporary copy of it, and then keeps a count and increments that copy pointer until it reaches a null. Effectively what this loop does is find the length of a string, length of a null terminated string. It could be the first location, could be a null termination character, or could be any number of characters. Okay, so in that version of length, the string s was not changed, and so we could have actually shortened everything. We could have said that we could have tried. It looks like reasonable that we could say s is a const pointer, but however this generates a warning, and so it's usually not done, even though it makes sense. We're not actually changing anything that s points to. So it makes sense to do this, but however it does generate a warning because it can't tell, right? C compiler cannot tell if you pass in s and you have the capability to copy that pointer. Well, you might change what p points to. Doesn't basically means that you will be changing what s points to. So it does generate a warning. Doesn't prevent you from actually writing such code and actually getting it to run as well. So we can simplify this loop in the last version, get rid of the warning by doing this. We can say that s is a const pointer, and we can use s open close square bracket with some index. So we're indexing into this array of characters, and this way if you don't use pointer arithmetic, you can actually bypass the problem that we had before, where the compiler was not sure whether you're changing something in s. When you use pointer arithmetic, the compiler is not sure whether you're changing stuff or not. It can't tell, so it'll generate a warning. But if you use array notation, which is probably what we should have used anyway, we can see that the compiler is sure that we are not writing to s, we're just reading s, and therefore this const is okay. So, and actually this probably also looks better. We have fewer variables. We actually didn't need that temporary p variable, because remember, we could have used s over here. We could have just said star s and plus plus s. Remember, that doesn't change whatever was passed into s, right? That would be just like a temporary value. So this makes a lot more sense. This actually looks better too. We say n is equal to 0. This is what we're really interested in, is the count. We check s sub n. Is it a null termination character? If it is, then this is false, and you exit the loop. And while it's not false, while it's not the null termination character, we bump up the count. Okay. So if a string is to be returned by a function, we need to allocate memory in whatever function is going to return that string. So for example, here is a function that takes a single parameter, a pointer to a character, and it'll make a copy and return a pointer to a copy of s. So it's not just returning a copy of that memory that memory address. It's not just returning a copy of s, it's taking whatever s points to, creating a complete copy of that string, null terminated string, and then returning the copy. So how does it do this? You can use malloc or calloc. Calloc is probably better because it'll zero out the locations, and so this is just like calling malloc. Remember, you need everything that s has plus the null termination, and this says that the size of each thing in that array is just 1. Okay, so we allocate memory, and here's the thing that you want to figure out how it works. Some of you might be able to look at it and just see how it works. It's pretty similar to the loop that we saw earlier, but all this is doing is copying each character that's pointed to by S into the memory location pointed to by Q, which is just the same thing. Q is just pointing to that chunk of memory allocated by calloc. Okay, so you want to test out a function like this. Copy string takes an input parameter that has some length. You figure out the length, add 1 to it for null termination, allocate that much memory, have p point to it, and then have a temporary pointer q, which goes through all of this memory that you allocated using calloc and copies everything from S into this new allocated memory, and then you return that. And so this is how you would use it. You have some string, you pass that in as a parameter to this new function, copy string, and assign it to some variable which is of type pointer to character, or it could be characters. This is how you want to do it. So you want to say car star, the destination is equal to whatever copy string returns. Okay, so we've seen a couple of loops. They have similar structure, and it's very common to see these extremely terse or succinct loops for string processing in C. So for example, here's a loop. Once again, the loop body is empty. So all the work is done in actually this Boolean statement. So this is a Boolean statement in C. Unfortunately, it is valid in C. It's not valid. You can't do anything like this in Java because this is so hard to figure out what it really does. So this is an assignment statement. This is saying whatever Q is pointing to, assign it to whatever S is pointing to, and then every time you access something, you post increment. So remember that the value of this S++ is just S, right? And then so this tells us, and then we dereference it, so it tells us that S has to be a pointer because we're dereferencing it. And we're doing pointer arithmetic at the same time. Same thing with Q. This tells us that that Q is either an int or a pointer. We increment it, that is, look at the next location. But remember that post increment, the value of Q++ is just the old value of Q before the increment. And then the fact that we dereference it using the star tells us that Q is a pointer. So here is the context in which you might use something like this. So if you haven't figured it out, you can think about it, and pause the video right now because I'll give you the answer. All this does is copy. It copies everything from S into Q. How does it know when to stop? Well, it knows when to stop that because the source should, assuming it does have a null termination character, eventually it will assign the null to Q. And remember that the value of this whole expression of this assignment is the right-hand side, the value of the right-hand side. So eventually when you do get to the null termination, the value of this whole thing is null, which is 0, which is false. And so you exit the loop. So that's how, once you hit the null termination character, you exit a loop like this. So this is the kind of loops, unfortunately, a lot of C programmers like to use because it's very succinct. Instead of putting a 4 or 5 line loop, you put it all into one statement. So now I'm not a big fan of this, but I just put it in here because you're going to run into things like this. You want to understand what it does. But plus, it's a common interview question to see loops like this written out, and they ask you to guess what this does. Okay, so for those reasons, it's good to know about how these loops work with strings. So if an input string parameter is to point to a new string, pass in a pointer to the pointer. So let's say you want to, for example, copy a string. And so this is sort of like passing by reference, but not. It's actually passing by value, but you're passing a pointer to a pointer so that you can change copy. So S is the source, copy is the destination. Since the value in copy is what you want to change by doing something like this, you need a pointer to copy. Okay, so try this out. set up a simple C program with this function and this main and print out the value in str2. This loop is basically what we've been seeing before. And the new thing about this is that we're using a pointer to the thing that we want to change. So this is, those of you who have seen pass by reference in C++, this works like pass by reference, only it's using pass by value of a pointer to a pointer. Okay, so try it out. I would say that's the best way to understand how this works. Okay, so you can use scanf. You've used that to read an int. So for example, if you have an int I, you want to read in some input from the user, you can use scanf. %d for decimal number, integer. And remember that you have to pass in a pointer. So it's sort of like this thing. If you want to change something, you have to pass a pointer. So scanf changes I. It reads in an integer from the keyboard user and puts that into I. So hope that makes sense. You've seen this before. This is basically how you would change something that's passed in as a parameter. Of course, we're passing in an address to the thing you want to change. Well, you can do the same thing with strings, but here the thing is you don't have to pass in a pointer to a pointer. You just pass in just a pointer itself, because of course whatever it points to, you can change that in scanf. So, and also you want to say how many characters. If you want to, you can say how many characters. It's always risky if you don't have enough space allocated for this for the string to take in all of the keyboard input. So typically you will say, I only want up to 9 characters for this string, and because I have space for 9 characters plus a null termination, that's a total of 10. Okay. To construct a formatted string, we can use sprintf. So how do you read this? You say string printf. So this is just like printf, except it doesn't go to standard out. It goes to a string. The output of the printf doesn't get printed. It goes to the first argument, which is a string. So let's say we allocate 17 locations, which will give us 16 spaces plus a null termination. So that's what S can hold. You pass that into S, and then you can pass in, just like you would with a normal printf format string with those % characters, and then all the things, a list of things. It doesn't have to be just one. It can be any number of things that you want to put into a formatted string. So let's count. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus 5 spots for a number. That's 16, plus null termination gives us 17. Okay, so I hope that makes sense. Once again, these are things you want to try out. If you want to do the opposite, if you want to extract data from a string, let's say you have some character array or a string, you allocate space for it, you put something into it, and you want to extract, let's say starting with these 5 locations. If you want to extract a string, extract an int, you can do that. Assuming j is an int, you can say scan from a string starting at location 11 using pointer arithmetic. Scan, get in 1 number, decimal integer, and here's where to put it. Okay, so you can output something. That is, you can create a string using sprintf from let's say using an integer into a formatted string. You can take that same string and extract the values in that string, or you can just take any string that, let's say, you read in from a file and extract values from it using string scanf. Okay, let's take we'll talk about the C string library in the very next video.